because I'm new to this thing, so I need your
Yes,
help.
it's visible. It's visible.
Acha. So easy trying to join. Okay, trying to join. Okay, this guy is joining. Okay, okay. So let's the participants. Keep this here. Keep this here. So. Uh, this is the first class. Bear with me. I just wanted to figure it out. Who is all?
what I didn't want.
Okay, let's do with this thing.
Yeah.
So the most important thing is what is GIS and why are we GIS is necessary. Okay, so GIS is Geographic Information System. Okay, and it is important because it deals with lot of location based analysis. So anything, any point, line, or anything that has a location can be used as geographic information. So this photo is taken at certain place at certain time. It's a geographic information. There is an area where at particular longitude and latitude. It's a geographic information. There is a particular application. Prashant Dhode entered the waiting room. Admit. Okay. Appears like that. Nice. Then I don't have to worry. Joining. Okay. Joining. Why joining? Okay. Put it this like this. Come on. Yes. So anything that relates to a location-based study is a geographic information system. So what kind of information generally and how does it relate to the data, knowledge, evidence, wisdom, and understanding? So this is the most important thing. Okay. And the slide, I mean, and the presentation will try to answer these questions. Okay. What kind of decisions you can make using geographic information system? Then how you or me or anybody know how what is geographic information system, or how is it, how can I use it for scientific purpose or research purpose, how do scientists use it, how do companies make use of it. So all of these will be discussed here. So the application of the GIS for the first time was done by a doctor in London to identify the cholera spread. Okay, so if you see here the black color, whatever you're seeing, these are all number of deaths due to um, cholera. So the doctor went around and found out because this area was having huge high number of chlorophyll deaths. I mean, cholera based death. So he collected all the things and he found that through all these locations there is a pipeline. See, the X marks are the pipelines. There's a pipeline. There's a pipeline here. There's a pipeline there, as in pump. Okay, the freshwater pumps are here. So he found out that people who drank. So these are the deaths. So people who drank from a particular pump, from a specific pump, got cholera more often, and people died a lot. Okay, so that was the first application of um, still joining. What? Okay, because that is the first. Okay, sound. Anybody has any prior experience with this kind of situation where people are joining and not able to join? Hello, Amit and
Yes, sir.
so you have any prior knowledge? Okay, this person is trying to join, but he's unable to join. Is there anything we can do about it? Is it a mistake from my side or their side? Because I never use Zoom. I use Google Meet. So hello. Please reply yes, someone please. ठीक है, no problem. Okay, let's continue. So he will come anyways. So the thing was, he found out that there is a pump here, okay, and people who drank water from that pump were affected a lot by the cholera. Now he understood that. How did he understand? Based on the relationship between the position and the interaction with the map. So that is the first application of GIS in the history. Then he found out that this pump is getting the water delivered to this pump is getting contaminated by the municipal water, or not the municipal water, drainage water from the locals and the industry. Whatever chemical water is there, it is coming into this the freshwater pump, and that's where people are drinking and dying. So that is the, and then when he stopped people from drinking water from here and removed the no the or corrected, I mean repaired the pipe work, then automatically people started recovering and number of deaths reduced. So that was the first application of the GIS in the world. So if I have to represent the same thing in GIS, GIS has certain things. Like for example, let us take ArcGIS. Everything in GIS is database, is points, lines, and polygons, or tables like this. So here, if you can see, every point is one depth, area, perimeter, depth, number of depth, one location. This is everything is representing one location. Okay, so depth, number of depths. So here is the x and y coordinate. Admit again. What is wrong? Yes, it is. Okay. Let me just sort this out. Okay. So, oh yeah. Hello, sir. Are you able to hear me? Prashant, sir. Hello. Hello, Prashant, sir. Is it okay? Everybody else can hear me? Hello,
Yes, sir.
Amit,
Yes.
can you hear me?
Yes.
Acha, okay.
Yes, sir.
Then
We can hear you, sir.
why is this person not? Hello, can you hear me, sir? Hello. Okay.
Maybe network issues.
Okay, no problem. So, but anyways, I will try to do this thing. So this is how you measure the data, and based on number of depths, you can represent GIS data like this. So number of depths is more amount of bigger circles like that. So that by visualizing only, by just seeing, you can understand that this area has huge amount of chlorophyll depth. Okay, and this fellow is the culprit. So there is a pipe here, there is a pipe here. Yeah. Hello, sir. Can you hear me? Hello. Anyways, let us forget that. So, so this is how it is. So this is the first thing, and then see, this is another representation of the same data set. Okay, of the same data set. This is another representation. So there is a pipe here, there is a pipe here. Based on certain analysis, you can get this kind of map. So in this thing, you're just representing your data for a visual introspection. So that is the best thing you can do with GIS. So that is the pump. So again, GIS is just can I ignore this thing? How do I minimize? Okay, fine. Anyways, so GIS is a geographic information system. As I already mentioned, it uses the location data, which is an important attribute. Okay, and it can be defined as a tool or a system or a database or whatever to go through your analysis. So same thing again, GIS was first implemented in the modern times. It was first implemented on a large scale by Canada to map their counties. Okay, similarly now everybody is doing. So there are multiple components in GIS like hardware, people who use the hardware, softwares they use, the data they generate, and the procedures they develop. So they have all of these multiple aspects of GIS, components of the GIS. So these are the components of the GIS. So first you have the data, then you have the information. Okay, then you collect the evidence, then you apply your knowledge to the evidence, and then you develop your understanding about the concept. Okay, so this is how you use GIS in the real world. Okay, so collecting information is through any open source or any, you can purchase the data through any sort of information like maps, uh, tables, or Excel sheets, or whatever. That is your information. Then comes the so you apply different techniques and develop a result, and based on the result you will grow your knowledge. Okay, that is what you do. So this is the flowchart. This is the steps you follow to do a GIS operation. First to take the data, then you have the information, then you have the evidence, knowledge and wisdom. So here you say, see raw data, you have the raw data, you develop the database, then you generate results, then you understand what the results is, then you develop a policy. So and the peculiar nature of GIS is, or the advantage of GIS is, it is multidisciplinary. You can apply GIS in multiple scenarios. So several multi-criteria techniques on screen. So and it is easy to digitize, classification, rasterize. So all these things can help you to apply GIS in multiple fields, very vast
Sir,
fields.
what was that image about?
Sir, hello.
Sir, what was that image about? The GIS one, the merits on the slide of merits of GIS one. This one.
This one. This is
Yes, sir.
basically I took from Google. It shows you the erosion or the road got destroyed because of erosion or whatever it is. Okay. So generally people were like, okay, how do I use this with GIS? So they, till now they were not able to join any geographic information with civil engineering department or anything that happened on the local. But now because GIS is there, because the location based studies available, you can just say, okay, this location had erosion. After 10 meters you'll find another thing, then you'll say again that fellow has a erosion. So now you know which areas of the road is problematic. In that way you can connect multiple scenarios or physical engineering based scenarios with the GIS. So that is what
GIS.
I wanted to show. That's all.
Okay.
Then this is the say it has the image processing, it has statistical programs, it has GIS, it has DBMS, WebGIS, and CAD. So these are the main inputs or the hands or the you know mm, the tools that we use in GIS. So we use image processing like satellite image processing or maps, whatever. Uh, then we have statistical programs like statistical analysis on what is great, what is near, what is far away, what is inside, what is outside. All of that analysis can be done using statistical stuff. Then you have a DBMS to store all of this data. Then you have WebGIS to export your data. You have WebGIS to export your data. Then there is CAD data. Obviously, there is before GIS there was CAD, and then people started implementing the CAD values into GIS. So GIS is a culmination of all of these things. So it is a multi. So that is why it became a multidisciplinary application. Okay. Then see, GIS is divided into three things: GIS service, science, and systems. So science may algorithms you can develop, you can analyze spatial patterns, database analysis, modeling. System is like your system is ArcGIS and QGIS, whatever you're learning is that tools. Then services is basically, for example, you want to develop a disaster management. For example, there is a fire hazard happening. You know, okay, this is a fire hazard, so there is a danger here. Don't go there. So you want to develop a web GIS service. So for that, there is a component called data. So the web services or all of that. So these three form the basic components of GIS. So this is all basic introduction. Current application of GIS, all of these things. So healthcare, delivery companies can solve geographic problems. I mean, based on they can calculate routes, schedules, transportation. Again, network analysis comes into picture. Geodemography consultants solve geographic problems when they assess and recommend where the best site retail outlets can be put. Like if I want to put a mall, I cannot put it under a flyover or beside a flyover. It is not possible. I have to put it somewhere where everybody can access it in the center of the city where there is no other mall, something like that, right? So people will use GIS for that kind of analysis also. And environmentalists like forest companies solve these issues, solve their issues by using GIS to know how to better manage the forest, where to cut the forest. Like this logging, Canada has this logging business where they log the trees for transport. So where to cut the trees, where to save where to lay the road, all of that they can analyze using GIS. Then there are many other programs. We can. I mean, I'll share this thing with you so that you can go through these things. So one example was when WTC was bombed in 2001. Immediately they used GIS to calculate where the plume is going, how to divert aeroplanes, how to save people, what is the restricted area. So what is this is where it happened, and this is the danger zone. This is the danger zone. So people were diverted from here or diverted from here. Here, no planes were allowed in this section. See now they map the danger zone. So this kind of analysis can be done using GIS. See again the same thing, the number of plumes and everything. And they said no plane should fly in this zone and all. So this kind of application is wide applied. I mean, GIS is wide applied into this thing. So these things are just an examples like Chernobyl disaster or anthrax disaster in Russia, which was averted, saying that okay, see there is a factory here, the plume carried the anthrax here, so people will get anthrax here. So anybody in this zone to move away from here. So this kind of disaster management can be done using GIS. See, this is the radius they created. Okay, this is a high hazard zone, low hazard zone, like that. See, this is how the anthrax spread. Similarly, we can do what is the safety, hazard, land use classification, land use classification you can do, land use change detection you can do, how the city is growing you can study, what is the core of the city. See here you can also study how people started moving from one zone to other zone. Some people were here living here, then they moved here. So you can do that kind of demography based studies also to understand why there is movement. That is all GIS. So basically, you can earlier days linking these two would be a very what do you mean by that? As in a huge type of very labor intensive work. But just by including location, just by including the location, you can do several analysis on the same data. On the same data, you can do multiple analysis. So that is how GIS will allow us to you know grow or do analysis. Same thing. This is how the people move from in the Australian sector. So these are all examples. Or you can say in certain sections they want to put a pipeline, then they will see the best route to put a pipeline where everybody can get access. So that kind of or electricity grid, how it is connecting. So you can do all of this planning using GIS, or you can also use the road network. So all of these are examples. See forest management, like if there is fire zone, non-fire zone, you can do all of that. You can also declare green zone where protected areas, all of that you can do using GIS. Then points indicate rate of burglary. So this is called crime analysis. Even police department can use to identify, okay, which area has more burglary. So that area needs more protection. So that kind of data can also be analyzed using GIS. So again, the federal government. So this is how, I mean, the structure. I mean, this is not much that important, but I'm just telling you how the decision is made by the governments based on GIS input. So you have the data, and then the organizations one by one to take the data, to take the decisions. So there are different aspects. Okay, there are different aspects of GIS problem. If for example, if somebody asks you okay, is this a problem, and uh, can I label this as a GIS problem, and what should be done uh, later. So for all of that, you have to define what is the problem first. So you have to define, okay, for example, let us take um, a common problem, traffic jams. Okay, let us take that common problem, take traffic jams. Now, is it local or a global process? Traffic, depending upon the government body that is looking at into the problem, it can be both local or a global scale. Generally, the traffic jams are at global scale, but for a small area, it can be a local also. So intent. So what will be your solution? Your solution will be a practical solution, or a science-based solution, or you're using to design a new methodology. Like for example, from New York to California, it takes 14 hours. I think it takes 14 hours, maybe 12 hours to travel through plane. So how many people are traveling? Around a million people travel a lot from these two states. So if we look at that and then say, okay, no, this is a very old method of technology, transport. Let us make a new technology of transport. That is what Hyperloop is. So that's how you design a new technique or a model or whatever. So for that also GIS is used. Then time scale, is it operational currently or will be operational, or you want to make it operational for strategic purposes? All of these things uh, can be incorporated into you defining the GIS problem. So you can incorporate scale, purpose, and time scale into a GIS problem. So if you are trying to define a problem for your research or for your whatever the uh, industry oriented problem, so you define the problem like this. So what is the scale, what is the purpose of this problem, of this solution, and when should I apply it, now or in the future, or should I keep it ready for tactical purposes? So like that. So you can apply these things for defining of GIS problem. Okay, and then how to approach a GIS problem. First is objective. You have to first define the objective, then gather the data required for the objective. Then you understand, okay, how to process this data. Okay, so you process the data, then generate the results for the data. So these are the four basics main steps. So first is you define the objective. Like what is the objective? For example, take a problem like water quality. Okay, in the water quality, what is the problem? I want to uh, detect if there is contamination in the water body, and how is it spreading. That is your project, that is your problem. So the objective is detecting contamination in the water body using remote sensing or GIS. Then the data gathering, then what you do, you gather the data. What kind of data? You go to the field, you either measure the data in the water body or use remote sensing to detect the contamination in the water body. Then after gathering, what you do? You will process the data. You will see how is different techniques, use different techniques and tools to understand how the contamination is moving up and down, like that. Those kind of mapping, measurement, monitoring, and modeling can be done. So this is all. I'll give you one example. So data collections. The details about the property are maintained on a tax assessment roll that includes information such as, okay, I did not do this, sorry. So there is a tax assessor's office, okay. Objective is to assign a value to properties using three basic methods: cost, income, and market. So this is the objective, okay. What is cost? Here, what is cost? Based on replacement cost of the property and the value of the land. Another cost is construction cost and vacant land cost. What is income? How much income a property would generate if it is rented out. Requires detail on current market rents and vacancy and other costs. So this is the data required for it. Then comes market. So market is most popular market, or where is it, compares property to the other recent sales that have similar location, size, and condition. So basically what is he saying? If I have a requirement of assigning a value to a property, I need these three data sets based on cost, income, and I want to rate the property based on cost, income, and market. So what do? I gather the data. What data? I gather ownership, I gather address, I gather land and building value, I gather tax exemption if there is any. Then I use GIS to locate these properties on the map. I want to locate these properties on the map, and then I'll say I'll develop a database, like it was like Kama or DBMS or whatever, and then I apply. See, this is how it looks. So there is a location. There's the properties of the information about the properties, and then I use the techniques or whatever, GIS analysis, proximity analysis, geographic and attribute query, mapping, reporting. All of these techniques I use to create a database or a solution, or you can say like online based. I can just go to online and say what is the tax on my property, I can get it. So that kind of information based system I can develop. So that is all. GIS helps you to analyze the data. So these are all. This is just one example. Okay. So scenario is don't. I've done. I'll provide you this thing. Just go through it. Okay. Is there? Let's see. Yes. Logistics and transportation. Risk zones. Yeah. So, so all these are objectives. Yeah, I think we will go with Amit. What is your interest area?
Sir?
What is that you are
Interest area?
interested? Yeah, interested. Which area are you interested in?
Sir, Odisha?
No. What is? Why are you interested in GI? That's all I'm asking.
Sir, oh sorry, sir. Sir, that's actually I belong to sir geology background. No, sir. Sir, I have read about
Geological.
sir, yes.
Mm-hmm.
So I want to relate all the geological data with GIS mapping and all that. So, sir, that's why interesting. I want to all the structures, and I want all the structures, geological structures, to be related with the GIS mapping types.
What is a geological structure? Can you define?
Geological structure.
Yeah.
Any
What is
type
it?
of any type of fracture, depression, or culmination, like anticline, silicon faults, or any type of fault. That
Oh,
is
so you deal with earthquakes.
yes, sir. Earthquakes. Yes, sir.
Oh,
Earthquakes. You can tell.
earthquakes, soil, property.
Yes, sir.
Oh, okay. So basically, you're trying to do this for soil and okay, that kind of analysis. Very nice. Then I can give you
Yes, sir.
examples like that only.
Sir, sir.
You'll understand it much better. Sir, Prashant sir, are you able to hear my voice? Hello, sir. Hello, sir. ठीक है, I cannot do anything about it now. Then we will do that because everything else will be boring for you. So, for example, this will be useful. Emergency evacuation. Okay.
Yes, sir.
So basically, whatever, if you have a fire incident, or if you have a flood incident, or if you have an earthquake, how do you how do you um, no use GIS in that scenario? So basically, you would say first you define your problem. How do you define your problem? I need to evacuate a household or a large area of people during a natural disaster like forest fire, cyclones, or some other disaster. Next comes second. What is that vehicles needed to evacuate people from the house? Okay, so what information do you need? How many vehicles do I need to evacuate people from so many houses, number of houses, number of exit points from the location, reduce bottleneck. So these are my guidelines. These are my guidelines. So this is how you define your problem. So this is how you define your problem. Okay, whatever problem you are dealing with, you define like this. And then you go with the data requirement. You say, I want census data because number of people who are living in that location. Then I want an estimate on number of vehicles they own. Then I want street information. Then I want where are the signals, where is the traffic, where are the bottlenecks and all I need. So these things you need. Okay. Next, analysis. What you do, you first find every street intersection and street connection to check for bottlenecks. If bottlenecks are die present, then you use alternative routes. How do you predict alternative routes? You use spatial interpolation, you use shortest path method, you use routing and proximity analysis, you use visualization to help people to escape. So this is one example. You can do. There is another example, environment. And so GIS allows us to compare the environmental conditions prevailing in different nations. Like for example, there is one study was the ice melting is one thing. Number of forest fire occurrence per year is one GIS study. Number of flood occurring is one GIS study. So all of these things can be done using GIS. And the uses examples, uncontrolled suburban growth, or whatever. You can use all of this GIS for all of these things. GIS can be used. For example, there is one example here. There is this thing. This is Bristol. So Bristol was like this, then slowly grew into like that, and then there is another city. This was the old city. This is Bristol. This is Brussels. This is Helsinki. This is Milan. So you can see that inhabitants per square kilometers. So basically, this tells you the population density of the city. So this kind of analysis can also be done. If you have, how the population is growing across. So this is Lake Erie, and if you want to estimate number of people number of houses coming at the the border or at the banks of Erie, then in this study, this is how you do the study. So now you see Detroit city developed into such a big city. So like that. Then comes deforestation. You can do deforestation analysis, how before and after forest fire. So before or after earthquake, or before and after a public, a sort of open environmental threat. You can do that. So data required is like pre and post. What is between the like land use data you want, uh, tree species you want, soil data you want, temperature data you want. So you compare both pre and post to see understand what is the impact of the study. So this is the one example of this thing. See, in this thing, 1999, this was the case. Okay, this was the case in 1999. Then in 2001, when they assumed a scenario where they said, okay, there will be huge coconut plantation or a huge deforestation. See, the forest has reduced a lot. So basically, this kind of analysis requires Markov chain models. So if you are interested in this kind of study, you need to understand what is Markov chain models. Okay, so you would use okay, you use this kind of red thing is like what? Red thing is arable land, so that is agricultural land. So all of a sudden it increased, it increased. So this can you can analyze, you can see that kind of stuff. In scenario two, their assumption is okay, no, forest will not be degraded in the center, in the middle, but it will be degraded in the corners. So you see the degradation is happening in the corners here. So the corner and the agricultural land is anyways increasing. So that is one scenario. Then you assume another scenario, there will not be any change in agricultural field. It will be protected area. If the forest area will be protected area, what else can degrade? Coconut plantation is degrading. Coconut plantation or grasslands are degrading. Yes, see the grasslands are degrading here. So they or else you can say
So
this
these are the
scenario.
models prepared in GIS. No?
Yes, this can all be
So
done
this is the
using
output, no?
Yes. This is the
Yes.
output. This is how it looks at the end of your study. This is how it should look.
Sir.
So in this scenario, see,
Sir.
this is grassland. This is grassland. Here they said that no, we will not allow any forest to go. We will protect it. So even the grasslands are converted into forest areas. You see. So that is the impact
Yes,
of
sir.
protection of forest. Okay, that's how you. If you protect the forest,
Yes,
this
sir.
will be the impact. So that's how you do GIS. Then comes GPS and survey management. So this is another topic. So till here we will like okay, GIS can be applied for multiple studies, and it can help you to form policies, develop your methodologies, develop your database, develop your analysis and knowledge base. So GIS can be a multi-tool, like a no, you can have multiple fingers and hands. So you can all the application is there, but it is up to your imagination how good you can use GIS, how good you can use GIS softwares or techniques or whatever for your application. That's all. It is up to you. One another aspect of development of GIS is because GIS needs location, the most important thing that was developed in 1990s was GPS, global positioning system. Why did they develop was, I'll tell you a small story. When Cold War was happening between USA and Russia, okay, they developed a plane called SR-71, and there is another, before that there was another high altitude flying fast moving plane. Then they understood that, see, whatever we are capturing the data, and they used to fly the planes over Russians were not able to catch it, destroy it. But the problem US was facing was, how do I know that whatever photograph I take belongs to this particular region? They did not know. They use stars. They use stars that are in the sky. I'm not because they are flying above the atmosphere. They can see the stars clearly. So they used to navigate using the stars. Then they understood that okay, we have to develop a positioning system for Earth also, so that we'll know exactly where a particular point is. Because of that, they developed GPS. So GPS consists of a huge constellation of satellites. Okay. Prior to that, they used to do surveys like this using triangulation methods. Okay. They used to do maps like this, topo sheets. But by the advent of GPS, now everything is like this. Your phone can be your navigator. You don't even need maps for that. So GPS slowly, that which was developed as for military usage, became a consumer product. Okay, these are the systems. I mean, currently active GPS systems right now. We don't want to call GPS because GPS belongs to USA, but you can say the positioning system. So Russia has GLONASS, Europe has Galileo, India has Navic. This is a local positioning system. It's only for India. It's not global. Baidu is again Chinese, which Pakistan is using right now. So they have a constellation of. So let us talk about Navik. In the Navik, they have a constellation of sort of satellites. So they have 3 satellites in geostationary and 4 satellites in geosynchronous. So continuously, we'll always have 4 satellites on our head, because for accuracy purpose, we always need 4 satellites to locate our position. Okay, for accuracy purpose. So we have satellites in the space, and based on the position of the satellites, we will know exactly where we are. Exactly where we are, we know. So that is why they developed Navik. And then the position is calculated by the distance. So basically, you are here. The satellite will send the relay, okay, signal relay and time delay, and say, okay, I am at this position. He is at this position. So the delay between the transmission gives you the distance. Similarly, these things will all do that, and they calculate the error for you. Okay, because they know the position of the satellites. Based on this positioning, they'll calculate your position error and give you the accurate position on the field to your device. So generally there are 24 satellite constellation. If you need global GPS, you need 24 satellites. But because we are not aiming for global GPS, we have only 7 satellites. So the components of GPS are 3 things. One is control segment, one is the satellite segment, one is the user segment. What is the control segment? It is a ground station. It says that, see, look, I don't need. It will always correct the error. It is like a ground station, like a TV station. It observes. It continuously monitors the position of the satellite. Then the user segment, which is you. It can be anything: aircraft, ground vehicles, ships, individuals. It can be anything. Then it is the satellite. So based on satellite position, the ground control station, and your position, again it is like triangulation only. Okay, and then you get the information of your position. But there.
So actually, how many? 7 satellites are placed over us.
Like this, we have satellites like this. But we need always see, these things are geostationary, but these things are geosynchronary. So basically, they will always be at this position only, constantly. Okay, but this
So what
is
is the meaning of geosynchronous orbit?
yeah, basically it's flying at the same altitude.
Okay.
They can change the position, but they always be there only. They'll allow you to monitor the position more accurately. There is 2 types of orbits: polar synchronous and geosynchronous. Polar synchronous, polar orbits are like this, from pole to pole. They go like that, pole to pole. Okay. All your satellites, majority of the satellites are polar coordinate, polar things. So they go from top. Here is my cursor, from top to bottom. Okay, like Landsat, Sentinel, Modis, Hyperion, whatever.
So only geostationary satellite will not do.
Geostationary satellites are stationary. They are at a single point. Always they look at the same point on the Earth. The altitude is 36,000 kilometers from the Earth's surface. That is why they are at the same position. Geosynchronous is they go at the same. They maintain the same distance from the Earth, and they follow the same path. They will not go top to bottom. They will not go like this, but they go like this, like this.
Horizontally.
Yeah. So that is how
In same
geosynchronous.
orbit.
Yes, that is how they help you to monitor the position of the your weather satellites are also basically geosynchronous. Geostationary.
Continuous monitoring.
Madam.
Continuous monitoring of the same this thing.
Yes, for example, weather satellites are there. They are geostationary. They'll be at that, and then continuously they'll be watching over the this particular zone, so that for any cloud information they can be used like that. Okay. So the errors because of this is, see, sometimes satellites degrade, so their position might change. So that error causes, for example, now when you observe a GPS location, it will say the error is between 20 centimeters to 2 meters. Yes, why do we get that error? Because the satellite will be somewhere flying, there will be a delay in the information. Sometimes the satellite will go up and down because these satellites are continuously falling. They need to be continuously put into the orbit again and again, as in again and again, as in small adjustment should be done so that they maintain the same altitude. But in certain cases, that causes more wear and tear, and you will not be able to put the satellite in exact position. So because of that also, you will have some errors. You will have errors because of atmospheric delay. For example, if you have a high cloud, highly cloudy uh, forecast skies or something like that, you can have more errors in your GPS location. You can have multiple paths. Basically, if you have a high skyscrapers, you have multiple paths, so the signal will not reach you efficiently. So that way, also there is an error, receiver error. Probably you might have some receiver error. Maybe your device is at fault. Satellite position errors, but all these can be conducted using DGPS, using differential GPS, where there is a control station, there is satellite, there is user, and in the middle there is another component that is movable object. So it knows its location always. So there is a multiple locations of receivers to calculate the
What is
error.
that component again? Which component in the middle?
In the middle it is a movable object. So basically they say that, okay, there is a,
Movable object.
wait, there is a monitoring station, major monitoring station. Then there is
Okay.
another object that is spread over many regions. Okay, for example, uh, for every state or for every city there is one GPS. Okay, GPS, a mobile GPS station. They will know their exact position. So now they will know, okay, so they will understand the error. Based on that, the error can be reduced. So more ground sites around the world, you need more ground sites around the world. So this is called the differential GPS. So receives GPS signal and retransmits, removes the atmospheric error, clock error. This clock error is because of the what is that, atomic clock error. Okay, all the satellites have atomic clocks, not our normal clocks. Okay, based on this thing also the accuracy can vary. So the accuracy was improved from 10 meters to 3 meters. Then comes kinetic GPS, which uses much more efficient transmission or signal processing to reduce the accuracy. I mean, to reduce the error and accuracy towards increase accuracy at centimeter level. So you have dual
So this has
frequency.
also movable satellite.
See, these are not satellites; these are stations. See,
Ah, yes.
so here DGPS matlab differential GPS. So how do I get that? Is because I have a different, rather than having one station, I have tens and 20, 100, like hundreds of stations around the world. So that will help in reducing the error.
No, no. One receiver is there. No, in the DGPS, one receiver is there. Movable receiver.
Hmm, hmm. I don't
In
know.
kinematic GPS also there is a movable receiver or a
Yes,
stationary receiver.
obviously, kinematic GPS also has many receivers,
Okay,
but
those
it
are
also,
movable.
yeah, it implies further
Okay,
signal processing to improve the accuracy. So it
sure.
uses dual frequency receivers, matlab better receivers. It can, so for example, probably at a lower radiance also they will, lower energy levels also they'll receive the information. So see, must have their own base station. This is basically used for lidar. Whatever lidar operations you do, they have their own GPS station put at a site. Okay, at a very local site. I mean, if you are doing lidar assessment or analysis or lidar mapping for a particular university, you will carry your own GPS locator. Okay, like a ground station, and put it at a place where you know the location, and then you do the mapping. That reduces the error to even centimeter level. So that is kinematic GPS. Yeah, that is the end of the.
So we are using GPS. After that, we are using the GIS mapping, right?
See, GPS and GIS mapping are independent. Okay.
Okay. There
For
is no relation
example,
between them.
I'll tell you. For example, do you see your Google Maps when you're traveling on bike or car? They'll say red color, high traffic, yellow color,
Yes,
medium
sir.
traffic, blue color, no traffic, or else free moving
Uh,
traffic. How do you think they know
uh,
this? How do you think that you know this? How do you think Google knows where? Because they are sitting in their office. How do they know
uh,
that this particular road is heavy traffic, this particular road has no traffic? Tell.
That's
Can you
so
guess?
satellites, no?
How can satellites detect vehicle movement? They take picture.
Oh,
That's all. They take only pictures. They don't even use drones also. How do they know? Tell. Just imagine. Anybody can tell. There is a. Ma'am, can you tell? Can you think about it?
Yes.
So are you not listening to the
Uh,
class?
yes, I'm listening. Traffic um, points, how they locate. You're talking about that.
Yes.
Maybe because from the uh, GPS locations.
Yeah. Okay. Fine. How do they get GPS locations?
Uh, from the from where do they get?
See,
That's a
the most rapidly growing thing in cities is cabs.
cabs.
See,
Yes.
they
Through
always
the
keep
vehicle
Google. They always keep Google active, Maps
active.
active. So they
Yes, yes.
calculate this fellow traveling from this location to this location, how much time it
Mm.
took. Based on
Yes.
that, they will predict the traffic on the road network. Yes,
Uh,
this is a GIS
uh-huh.
application.
Yes.
Okay, location based application. But what is
Mm.
the input is your GPS.
GPS.
Position, your location is the input. Yes or no? So that's how they
Yes.
calculate. GPS is used for many things. For
Basically,
weapon.
coordinates in the GPS.
Yes. They
Um,
will use it for weapon delivery. They will use it for identifying persons. So for example, you must have seen in many movies. GPS locator will be hidden in a bag. They will go.
mm,
The guy will know. Okay, this guy is here. How will they know?
mhm.
GPS. So all of that and that same thing. See,
The
GIS.
lat that will be
Yes,
stored.
absolutely. Yes, it will give you everything. Lat
Mm,
long, time, duration, movement, everything will give based on the location.
mm,
GIS is a software that analyzes the GIS GPS positions and draws all these relationships like this fast
mm,
moving, slow moving, stagnant. All this happens because of the GIS only. Now I'll ask you a few questions.
mm.
Okay, in your own field, please give me 3 applications of GIS in detail. मतलब आपको you have to tell me how GIS is used there, or if you understand, you must have already seen it. You can tell me. You must have done it. You can tell me, or you just have an idea. You can tell me. No problem. You just have to tell me where GIS is applicable in your own field. I will start with Amit because it is A.
sir,
Tell me.
sir, in geology, it is used for to locating the faults and fractures and all that. We can locate no all that structures and all that,
Can you tell me how can
the
you locate
joints.
that? No, I am asking you, can you tell me how to locate? What will you use?
Sir, first of all, the position and the location, the lat long will require of that
Of
area,
what? Of
particular
what?
area,
What is, see, you are telling,
in where the structure is present.
okay. What is the structure here? Is a building? Is it a building?
Suppose a dome structure is there.
Okay. Okay, let us take Taj Mahal. Okay.
Yes, sir.
Taj Mahal has a dome. Okay.
Sir.
Now you are telling me that I will use GIS to map cracks in the dome. Is it true?
No, I'm not actually talking about that dome, that small hills, sir. We call that dome in geology, sir. The
Oh,
small hills.
okay. I thought that dome. Fine, my mistake.
No, no, sir.
So there is a mountain or a hill or something
Sir.
like that,
Okay, sir. Yes, sir. Huh.
and you want to
Suppose in
map that
that
hill
we are demarcating, yes, sir. We are demarcating the faults and faults present there, or any cracks,
in the dome in
or
the
the
hill.
rock types present there.
Acha,
Yes, sir.
acha. So basically, you will create a GIS database where you say the position of the rock,
Sir.
the type of the rock,
Sir.
does it have a that
Sir.
is that does it have a field lines or some fault line, something like that? Yes, right?
Yes, sir.
Okay,
Yes,
okay.
yes,
That
sir.
is one application. Second application, please.
Sir.
Second application. Can you think of a second application?
Sir, yes, I'm thinking.
Mhm.
Sir, we can locate the springs, the springs, the natural springs or geysers.
Absolutely, very good. So you want to identify the location of natural springs.
Yes, sir.
Okay. Third application, please. Think big.
Sir,
Think
the
big.
deposits, mineral deposits and all that.
See, you are following the same trend. पहले घोड़े को I detected a horse, then I detected a goat, then I detected a fish. Think about something
Sir,
else,
I'm
na?
telling you of my field, no.
I understand. In your see, you can do much more things. Okay. For example,
Yes,
I'll
sir.
give you for a small thing. Okay, you told me, sir, I want to detect geysers. Okay.
Sir.
Then you will say, sir, there are geyser here. Why there is no geyser somewhere else? Then you will say, sir, there is a vent. There is a vent
Sir.
to the mantle. So you have that heat coming up. So you have a geyser. Then you will say, why
Sir.
only magma coming here? Why not somewhere else? Then you will say, sir, there is the thickness of the crust. I am asking you, can you map thickness of the crust at every location using GIS? Is it possible? Can you think of a situation like that?
Thickness of crust.
Thickness of the crust. You can do it, right? Yeah. So that is where GIS is used. That is the that is how the GIS is applied on a global scale. It's like, okay, see,
Sir.
this particular region crust is thin, so you are getting geysers here. This particular region, the crust
Sir.
is thick, so you are not getting even earthquakes also. Then you will say, okay, there is fault lines. How did people understand there is fault line here? It is spreading there. There is a news coming from no, maybe 2 3 years back. There is a news where Africa is splitting into two again. How did they know?
Sir.
Because of this GIS application on fault lines only, no? So that is how you have to think.
Sir.
When see, I am
Sir,
giving
but
you
can we know the underground thickness using this GIS software?
no. You measure the underground thickness and you
Yes, sir.
maintain
Yes,
a
that I'm
database
telling.
using GIS.
Yes, sir.
Maintain a database and you analyze using GIS. So GIS is a
Sir, yes.
tool. Data you
Sir.
have to acquire. It is your scientific
Sir.
data acquirement is what you have to do. ठीक है मैडम आप
Sir.
बोलिए.
Sir, in order to check the degradation of forest, like
Absolutely,
where
that is
the
just
types uh, I can analyze, right?
yes.
That can be one thing. Then, like, what was the reason? Like, then again, I can correlate that with, I guess, the weather situations.
Okay,
I
weather
don't know.
situation. Yes,
Maybe.
that can. No, that is true. You can do it. हाँ. Okay, next.
Okay.
दो हो
So
गया ठीक है.
maybe then, mm, what else? Again, how? What more can I do? Is mm, mm, wha- I don't know. What are these? I don't know. That much I
Okay, fine.
think of.
No problem. No problem.
Mm.
So, okay, sir, will you be able to share some views, Prashant sir?
Yes. About what? About Africa?
Nahi, sir. How
Uh,
GIS can be applied?
Okay. GIS has lot of application in geology. Basically, we start with the mapping. So all these say like a fault location or mineral deposit location or stratigraphy, building stratigraphy, uh, building the beds. Everything is comes under mapping. And
Acha.
when we do the thematic mapping, basically in GIS we do the thematic mapping, which is we take the theme, one theme, like you can take a stratigraphy, one theme you can take a structural geology, one theme you can take a geomorphology.
Perfect.
So the
Yes.
advanced use is like a mineral exploration or environmental geology or medical geology. We use a fuzzy logic rather than using only one information. We take the all the layers, all the thematic maps, and
Hmm.
then, like he said, we can estimate earth crust. Yeah, we can estimate, like we can have the one map of the heat flow,
Hmm.
another map you can, yeah, you can use the earth structure,
Hmm.
third map, you can use the seismic data, uh, the focal point mechanism or depth mechanism, where from this all seismic triggers is coming. So yeah, because I use this once for my Himalayan geology paper. So,
Hmm.
and then you can combine these two data, all these data together,
Hmm.
using some logic. You can create, then estimate the indirect property. So that is the
Ah.
second. Mineral exploration is the third, where we use uh, GIS very much, because mineral exploration, this is the culmination of the taking all data together, not one data. Like, so that all data we need to process together. So we use GIS there.
Okay. Very good. Thank you so
And
much, sir.
just I want to add one thing
Yes.
very
Yes. Yes.
near
Yes.
to my heart. Nowadays, there are my friends also using GPS and GIS together
Yes.
to understand the, you can say, to understand the crust movement. Like you
Yes.
said, the GPS, just they put some stations uh, all over India, in Himalaya, and even they some take some data from the Tibet, and
Yes.
then they see how the crust is moving, how our plate is moving. That is
Hmm.
one, and there are some other application which is like using GIS and GPS together. My one friend created one map that every, because he has a very good GPS, so how the structural trend is changing every 5 meters, and then from
Hmm.
then he calculate the strain partition.
Fantastic, sir. Fantastic, sir. See, I was mentioning there is a super advanced GIS user joining us. So he is Prashant. So glad that you are here, sir. Thank you so much.
Thank you.
So that's the basic app. See, you need to understand three things. I mean, I'm talking to Amit and Kapil Sharma. So,
Sure.
so you when you're trying to define a problem, okay, whatever problem it is, research or whatever your country, I mean, company based or industry based, whatever. Always need to understand the problem in three things. What is your requirement? What is your problem statement? Uh, in detail. So, for example, it should never be vague. Like, okay, in the starting it can be vague, but it has to come to precise level, ekdam precise. I will do this with this about this for this long. That's all. That is your objective. Then you will search for the data. Okay, data can be anything. GIS data, I mean GPS data. Um in case of forest fire, you can say area of frequency of forest fire, area where it is occurred, area damaged, species of water, I mean plant species damaged, In a geological perspective, it is fault lines, soil types, rocks, is it sediment or metamorphic or whatever. Then it comes, is there any mineral there? What kind of mineral data I want? Thickness of the soil, thickness of the crust, whatever. Third thing is, how do you collect the data? Do you go to the field and collect the data, or do you already have the information? So you collect the data. Then comes cleansing of the data. Not all data is clean. So you get the data, you observe the data and understand, okay, this for this particular thing, for you to understand if the data is clear or not, is good enough to collect is not, you need to have a good knowledge about the field. For example, okay, there is a common conception that there is, okay, let us go beyond our earth. There is a common conception that uh, hydrogen is the uh, most abundant element in the entire universe. How do you know this? Can you tell me how did you know this? They understood this using spectrometer or whatever the they are used for gas identification. They use that they identify. Imagine they understood that, okay, there is some error in the machine or there is some error in the process. Suddenly you find out that the most abundant element is not hydrogen, but it is argon or nitrogen or oxygen. Then you're wrong. That means you don't understand what you're doing. You are, because you are not able to understand, you're not able to pick the problem or mistake that your data has. So always correct the data, see if the data is correct. If you can't analyze it, ask some expert to give their views. Then you use the data to assimilate whatever the results you want using GIS tools. Then once the results is there, it's that they should make sense. For example, rainfall is falling. So for example, there is ice is melting in the Atlantic Ocean, but your data says there is no temperature increase in the on the Earth. Then that doesn't make sense, no. There is increase in temperature by 0.25 degrees. You seeing high melting in Arctic Ocean. So that is correlation, right? So that kind of your results should make sense to you, to your research or whatever the study you're doing. Then you apply the knowledge. Okay, if this is happening, what could it lead to? What will it be in the future? What can it do to the process? Then you make a policy. So that is how the GIS thing works. Agreed. I mean, this is basically a theory, nothing very solid for your learning as an RGIS and QGIS, but this is just a introduction. So we are done with GPS and GIS concepts. One assignment I'll give you is to make 10 applications. Write down in an Excel sheet 10 applications in your area or any area. It's up to you. 10 applications, data you require from that for the data for that application, and what will be the output you expect. I mean, what kind of output you would expect from that application. Like that, you make 10 things, 1 to 10. You make 10 applications like that, and you have to show me by tomorrow. Okay, we will discuss that one by one, so that will help you.
Sir, only the application of GIS or the result also.
See, that is what you have. You should have three columns. First column is the application. Second column is the data you think is required for that application. Third thing is what is your understand. I mean, for example, you have fault lines. You apply GIS data for that. What will be the outcome? What will be the expected outcome? So that you have to mention. You have to try it like that. You have to write 10 examples. So and then you're telling me. Okay. So let us do another uh, thing here. Datum. Yeah, this is the most because I want to finish this theory today so that okay. Am I sharing my screen? The screen is paused.
Yes, sir.
Stop sharing. Okay. I think I'll share another. Oh, this is a huge slideshow. Oh my god. Maybe I'll complete this tomorrow. I don't know. Am I recording this thing?
Yes,
Recording
sir.
on this company. Yes, we are recording. So I'll supply this to the other candidate. No problem. Okay. I will anyway supply the PDF to you. So don't worry about it. So here, the most important part of GIS is projection and datum. Okay. No matter what data you have, no matter what data you have, finally you are representing the location based analysis. Yes, you are representing a location based analysis. For that, you are making a map, you are making a statistical value, or whatever it is, whatever your output is. For that reason, you putting you measuring, or you are referencing the data for the datum, or the whatever the local or global datum or G projection system you use for your location. Okay, that is the most important thing. Most important thing. Okay, so why projections are important? So there are, like, see, at present there are more than 400 projections. Everybody develops their own projection for their own need. If the other projection systems are not suitable, are not helping them. Okay, so they are basically most important thing when you're dealing with RJ, I mean whatever GIS based studies. Why projections are important? So uh, okay, this is the most important thing. Okay, so where the projection is centered alters where the project, what, okay, I'll tell you what is, first I'll define what is projection for you. For example, you have a globe, right? You have Earth. Earth is not a complete circle. If it was a complete circle, lot of our problems would have been solved very easily. But it is not a complete circle. It is like a ellipsoid or a orange. It's like an orange. Okay, small flat surface on the top and bottom. Okay, so when you split it, so that is a 3D object. That is a 3D object. Now you are trying to do analysis and present the results. You cannot present it in a 3D, right? You have to put it in a 2D. So what did people started to do? They, earlier days they used to cut. I mean, cut matlab imaginarily they used to uh, cut the earth at Greenwich and spread it like a rectangle. Okay, like this, like this. They cut the earth at Greenwich, and they used to spread it. So this is how the, or else here it is cut at Bering State, but earlier it was near. It was considered to be 0 degrees latitude. I mean 0 degrees longitude. That is Greenwich. So they are trying to make a 3D object into 2D. Okay. Now projections and datums are very important, because how accurately does this 2D represent the original data in the 3D earth or 3D surface. Okay, or based on that, the projections, the datums, the accuracy of these part vary, and application also varies. Okay, that is where projections are very important. Okay, so for example, I am studying India. I am studying the properties of India. Agreed? So my projections have to be perfect for Indian scenarios. Sometimes you can use global scenario also, but yeah, you generally will use the thing that is perfect for your country. The survey of India, whatever the survey of India does, no, for India, they use their own customized projection system and datum, LCC, Lambert Lambert conical. Okay,
Yeah,
LCC,
polyconic.
conical. So they use that for their analysis. Okay, so based on that, based on their requirements, based on the position on the earth, position of based on the research you do, there are several projection systems developed. Okay, but every projection has these three properties, these three distortions: projection center, map scale, shape used. Based on these three things, there are many distortions that occur in the projections. Some examples are given here. This is sinusoidal, this is Mercator, this is conformal, or you can say compromise, something else. So based on your artistic thing, you can develop like this also. So how do you select a projection for your need? Select best projection is not possible always, because there is always a compromise. Every projection has a pro and a con. No projection is accurate representation of the earth. At least till now it did not come. Either it has some issue or people don't want to use it. Trade-offs need to be made. Okay. So here again the same thing, 3D to 2D flat. So we need projection system. For example, so here generally we use latitude and longitude data. Okay. Models approximate the shape or size of the earth as an ellipsoid, a sphere, etc. Then we apply mathematics. Then we develop. Okay, we take the overall shape and aspect into our consideration, and we divide. We develop projections. So there are several types of projections. What is that? Equal area projection, conformal projection, equidistant projection. I mean, these are the properties. These are the properties that we want to save in a projection. So, for example, if I say, for example, this is just for example, if I say the area of Rajasthan is X square kilometers. If I use a projection that does not save the area, okay, then the area of Rajasthan according to that projection will become Y square kilometers, which is not accurate. So we need to use a projection system based on our needs. So if you are trying to calculate area, we need to use a projection system that saves area, that protects the property called area. So there are certain distance, shape, azimuth is distance, or compromises between all these properties. Equidistance is again the relationship between distance between 2 points. Azimuth is direction. Conformal is shape. For example, in certain cases you want to provide a shape of earth which accurately shows the shapes of most of the continents or countries. So this example is like that. This is like that. It gives you the proper shapes, but the areas are distorted. See, Greenland is way larger than Africa. Well, it's almost 3/4 of Africa, which is not true. See, this Russia is too long. This is not true, because there is some error in the projection system, but it shows the accurate shapes. In certain cases, if you see here, in this case, the shapes are distorted here, the shapes are distorted, but you will see that the areas are protected in some cases like that. See, this is, so based on your application, based on your need, you choose a projection system. Okay. Then these are the Cartesian coordinates, like mathematics, x and y location, p, x and y. You have this location is represented as p of x and y. This is how latitude and longitudes are used generally in maps. X will be your latitude, y will be longitude, y will be your latitude. So based on that, you will get the position of the object, latitude into longitude, or comma longitude. That's all. So this is the Cartesian coordinates. Now the concept is how to get this Cartesian coordinates from the 3D coordinates. For that, you use this cos theta and sin theta application. Okay. So people have used that cos theta relationships. For example, there's a point here in the z-axis. So they will calculate using the surface of the earth is here, the center of the earth is here, how much distance from the center to this particular position. If I draw a tangent, how much is the distance here, how much is the distance there, and they'll calculate. For example, this is how they calculate the position of the object on the earth. So this is the center from the Greenwich. What is the longitude? I mean, 50 degrees longitude east. Then the latitude is 40 degrees to the north. So based on that, they calculate the position of the object. Okay, that's how generally it is done. Later, they developed new methodologies to develop new methods to detect the position of the object on the Earth's surface more accurately. That is geodetic and geocentric. I mean, this you don't have to know, but then just I'm telling you for your understanding. So later, what they did, they understood that it is hard. It is getting hard to monitor positions on the Earth. So let us develop a datum. Okay, what will be the base for the datum is the gravity of the Earth. Okay, so first they developed the gravity recovery and climate experiment. So they developed a model where based on the gravity, the Earth shape is modified. Okay, based on that they will understood and then they developed a spheroid. What is a spheroid again? They average all the heights and all the depths of the Earth, like complete Mount Everest say what is that, the Marina Trench. So they took all the heights and lows and they averaged you calculate the mean height of the Earth, and they put a ellipsoid through that mean region and call it as ellipsoid spheroid. And right now, like it is like mean sea level. Right now, it is like a mean sea level from where the heights of the lands are calculated. So they calculate this ellipsoid. Now you have this gravity model. Based on these two things, they developed a complex model. Okay, they developed a complex model, complex ellipsoid. This is also called as datum. Okay, based on this, suppose I want to, for example, see somebody is interested in this region. They will develop their own datum to suit this particular region. How do you develop your own datum? You create a spheroid. Matlab, what is spheroid again? The average of all the heights and depths of the Earth. Okay, that is what. So that it clearly gives you the average shape of the Earth. It gives you the average shape of the Earth. And how do you control the shape of this ellipsoid using the B and A? That is longer the diameter and smaller diameter of an ellipsoid, and based on that you make different shapes. For example, I am interested in this location and also this locations. I will change the values of A and B so that these two locations will be accurately represented by the ellipsoid. So like this, they developed several datums, okay, for their local use. But for international use, for generally for all purposes, they have developed one particular thing, or that is right now everybody is using, that is called WGS, World Datum 1984. That was developed in 1984. Okay, so World Geodetic System. The name is World Geodetic System. What is geodetic again? This thing. Okay. So like that, these are all examples. So based, for example, if I choose datum, different datums, okay, for every different datum you choose, datum, by datum I mean that the average of all the heights and depths of the Earth's surface, that is the datum. Okay, so based on different datums.
That is spheroid, no?
Yeah, that's what. Spheroid is nothing but your datum.
Same, okay.
Yeah, as far as spheroid is nothing but datum. So based on that, you get different altitudes or distance. Okay, so it's like ideal geoid or spheroid, whatever. Same thing. Gravity based geoid is spheroid is called geoid. Okay, same thing. The concept is the same thing, but the data used to generate that spheroid is called as is different. For example, for geoid I use this gravity model. For geoid I use this gravity model. Okay, I use this gravity model. But for spheroid I just take the altitudes and valleys into consideration. That's all. There is no difference. I mean, concept is same. We are trying to average out all the undulations on the Earth's surface so that all the features on the Earth exactly fit on the surface of the geoid, on the or spheroid, okay, or ellipsoid, whatever. So like this, see, there is altitude, they measure of the spheroid, and they develop the geoid and spheroid. They develop that thing. Then look, there is a difference between. Then comes the I already told you, right? So the world has developed WGS 84 as a current datum. The most effective datum right now we are using is WGS 84. There are corrections that are being made to this also. There are corrections that are being made to this also. Okay, still. Then comes local spheroids or geoids or whatever. This thing is again used to measure the local aspects. For example, if you are only using for India, you will develop your own datum. India and Nepal has single datum. You will develop your own datums. So here I am showing you the example of global versus local datum. Okay, global versus local. See, this is local datum that fits only this region. What does the global datum do? It almost fits all the regions. Okay, but this region is really high. So you develop your own datum to get more accuracy. That's how global datum and local datums are being developed. So this is how they affect the datum. The choice of datum affects your results. This is the altitude of the area in England, okay, or you can say actually temperature, whatever. So here you see using global datum you get this kind of values. Using local datums you get this kind of values. You see, that's how the variation can occur. So based on the local and global datum, your data varies. So choosing the datum is the most important thing. But if you are using for India, you can always go with Everest 1830C datum. I mean, at least that is what we use. Okay. So, and then comes the projection. Once you choose your datum.
There is new pattern.
Hello?
I think there is one new datum. Yeah. Okay,
Maybe.
for our purpose is okay. There is one new datum.
Okay. Can you name it, sir?
It is in 1973 now.
1973. Yeah. Okay. I think I missed it somewhere. I think it was there in this table. I did not put it. 1973 is a new datum. Yeah, correct. I agree. Thank you, sir. Then comes, so once you select your datum, okay. Once you select your datum, you have to choose your projection system. See here, this WHS 84 is datum, but the projection is something else, Mercator projection, something. So based on the projection and datum, you will get different variations in your representation of the data. And also see, this is how you.
How these projection are named, that Mercator and UTM, like that?
I don't understand.
Sir, these are the name of the projection, no? Mercator's UTM zone, that one.
These things, see, this is Mercator only. This is UTM zone 11. This is a projection. This is National Atlas. Is a projection. This is another. I mean, this is datum and projection. EPSD 4326. This is GCS, Global Coordinate System, what lat long position. So the datum is WGS 84. Like that. Then see the. So imagine this is Earth graticule. Graticules matlab your latitude and longitudes. Okay, based on your projection and datum used, you can get any of these results. Okay, for example, here you can say I want to protect the shape. This fellow protects the shape. I want to protect the whatever, some parameter or distance, whatever. But you see, there is an error in everybody. So your choice of projections become very important. Datum is used for accuracy. Projection is used for representation. Okay. Map projection is a process of transforming local location on the curved surface of the Earth with the geodetic coordinates to planar map coordinates x and y. Okay. So there are three types of projections surfaces you use. So what do you do? It's like projection is like your light projector. You put a object between the light and a wall. So you put the light on the object, the other side on the wall you get a shadow, right? So that is what it is. It means you are projecting the earth to a particular wall using a light source. That's how the projection has been. I mean, that is how the initial concept of projection was developed. So for that, you use three surfaces, like walls, you use three surfaces: perspective, conical, and cylindrical. Okay. These property, these whatever the projection planes can be applied in normal, transverse, and oblique aspect. Based on which surface you take and how you apply it, you will save conformity, that is shape, equivalence, area, equidistance, distance, azimuth, directionality. You will save any of the, at least two of these properties can be saved. Okay, but not three or four. It's not possible. Okay, then comes based on uh, the position of your plane. You can develop, mm, develop a bigger map or smaller map. So inside tangent secant can also be used. So for that is basically the example. See, this is one example. So here the earth is, this is the earth. I put a flat surface like a plane touching the equator. Now I imagine I put a light source on the center of the earth and a project. Okay, here the light ray meets here and falls on the plane here. So this point on the earth is mapped here on the plane. Like that, all the points on the earth surface are mapped. So like this, the 3D globe is converted into a 2D planar. And based on this location of the light source, or from where the projection is being projected, stereographic or orthographic, you will get the accuracy levels. Okay, so here the accuracy levels is very small here in these regions, but if you go to stereographic, the accuracy levels are much better. But if you go to orthographic, the accuracy levels are even better, but the area covered is very less. Because of the curvature of the earth, you get all these problems. Okay, so you have a polar transfer. I will talk about polar transfer oblique like this just now. Okay, see, this is how you see the earth. Okay, this is secant, this is tangent. Tangent is a plane touches the earth surface. Secant is it cuts through the earth surface. Okay, so this is how the map. This is how a map is generated after you apply this planar. It's like taking a photograph. Just taking a photograph. If I touch, use a tangent plane, I'll get an earth photograph like this. If I use a secant plane, I'll get an earth photograph like this. Now you can ask me, what is the importance of secant and tangent? See this, because the problem is, because of the earth's curvature, as you move down, as you move away from the plane, the error in the representation of earth surface on the 2D plane distorts a lot. Okay, so you always try to find ways to increase the accuracy. So if you are interested in studying areas on this latitude, you putting your plane on poles doesn't make sense. Okay, because the accuracy reduces. So what do you do? You take this latitude as your center, latitude, and then you develop a map. You get better accuracy. That is where tangent and secant were developed. Okay.
But we will get better accuracy in secant rather than tangent.
Yes, you get better accuracy at secant only in this region. But you go to pole, if you say, for example, if you want to do research, do work on poles, you cannot use secant like this. You have to use tangent like that. Okay, for better accuracy. That's all. Then there is again normal, transverse, and oblique. What is normal, transverse, oblique? I think I put a yeah. This is normal. This is transverse. This is oblique. You can apply cone, you can put cylinder, you can put plane in this format. Okay, this is inside, this is tangent, this is secant. Based on your position, based on the position of your plane, you can get different projections. If you have a gnomic light source, you'll get a projection like this. If you have a stereographic light source observation, you'll get a map like this. If you have an orthographic light source, you'll get a map like this. But traditionally, most importantly, for all the work we do, we use three things. For India, we use LCC, conic, that is conical projection, conical surface. Okay, conformal conical. Then we also use UTM, Universal Transverse Mercator, with WGS 84 as datum. Then you use GCS, Global Coordinate System, with WGS 84 as datum. Okay, because these three things will give most accuracy to India. Whatever the work you do for India, you'll get better accuracy at this particular three things. But if you are in northern plains like Netherlands or Russia or Europe or Canada, you use cone. You use cone that fits either secantly or tangentially to that particular zone, and then you develop your own maps based on the position. See, this diagram tells you based on your position. See that this is tangent, right? This is wherever the cylinder is touching. Wherever the cylinder touches, the accuracy levels is really high. The more the curvature is, the more the error. Here there is large error. That is the reason why some people use secant. So there is less error, more accuracy, less error, very bad. So you'll get the error is less in more of the area. So that's why people use secant in general. Then this is same thing. This is transfer muscular. I'm just giving this basic thing. So see, this is the scale factor error. So basically, what is scale factor? How much accurately your map represents the real world surface. If scale factor is 1, then there is no distortion. If the scale factor is less, then there is most distortion. If the scale factor is greater than 1, again there is distortion. So if there is scale factor is less is 1 or very close to 1, then there is less distortion. So wherever the plane is touching the globe, you will have very less distortion. That's how you develop most of these projection systems. Okay, so this is conical. This is how you represent a conical surface. This is where, because the India falls on the curvature, we use conic. Again, there is secant, tangent, and everything similar to the whatever the concept I explained you till now. So this is the example. If I use a conic, I get a map like this. If I use a globe or a conformal or a compromise, I get a globe like this. If I use a cylinder, I get a map like this. Is the map you are used to, because this protects the shapes pretty well. That's how. And then this is not required. I mean, this is for some other things. And then yeah, this map tells you based on the secant or tangent you use or type of surface you use, the error. See, for example, this was secant. This was secant or you see the error is less here. Matlab, if the shape is circle, then there is no error. If the shape is this ellipse or like this, then there is more error. So if you see this, there is less error here, there is more error here, and there is highest distortion here. This tells you what it's a cylinder, it's a secant, and that's what. By looking at the map, you can tell which surface was used for projection. Okay, and then based on your property you require, do you want to protect area?
Can you explain once more that diagram?
Yeah, again, okay, these are called Tissot ellipses. I think there is a best example here. Yeah, this is the best example here. Okay, this map was orthomorphic or orthogonal. This is okay. Anyways, I'll edit this later. So you see, these are perfect circles, right? What does this tell you? This map tells you that there is less error here. Okay, this basically tells you that each map protects one property. Okay, each map protects one property. This map protects distance. If you see this to this to this till here, the distance is consistent. So this map protects the distance property. Okay, and it also protects the shape in this location. So for this looks like this. If I go back, yes, this is what they used to develop this particular map. Just by looking at the map, you can say that this map, this projection system captures the distance very nicely, but there is distortion to the top and south, to the poles. Okay, when you go to higher latitudes. Then comes another projection system that accurately protects the shape. So if you see, the shapes are accurately preserved, but there is distortion in the size. You see, there is bigger circles, smaller circles. So this projection system, even though it uses the global datum of WGS 84, it protects only one component or two components, that is distance and shape, but the size is distorted. You see, there is huge size of Greenland. It is almost equal to Africa. That is wrong. Greenland is actually far less, even very small compared to Africa. It just fits here. But why is this? Because of the projection system you choose. Okay, that's the most important thing. Then there is another parameter, that is this thing. You see, this protects the distance because the points are at equidistance from each other. Till here it protects the shape also, but from here the distortion happens. So what does you know from the map? That this projection, whatever this projection, what is this projection? World map equidistant cylindrical. So it is equidistant cylindrical projection. So it's from the name only you will understand that this protects equidistant. You see, the distance is saved, but it is generated using a cylindrical projection. So based on these circles, you will understand that that is equidistant and cylindrical. And one more, this is this is compromise. In this thing, the distances are saved, but there is small error. The shape is almost saved, but there is small error. The direction is saved, but again there is small error. So based on your, it's like overall jack of everything, master of none. This fellow is like jack of everything, master of none. So you can use that compromise section here. So these are the conic. This is how conic is represented. Maps. Okay, I think till now the theory has done. I'll cover the maps tomorrow in the next class. So this is all diagrams. Most of these things are diagrams only, so that else I can cover this thing, and next class we can go to practicals. Yeah, let's do this. Bear with me for another 10-20 minutes. I'll finish these things. So your target of choosing projection is to represent your analysis or the results of your data of your analysis in the most precise way, right? So that is depending upon your data, the location, and what you want to show, you will choose datum and projection. For example, if you want to show India map very accurately, all the areas and shape, you will use our local datum, our local projection system. But if you are fine with only shape, but I don't want shape also, I am concentrated only on area, then you can go with UTM. You don't want any of those, you just want India map, you can go with GCS, global coordinate system projection system. Okay, based on that, based on your requirements and based on what you want to show, you choose your projection and datum and your location. Okay, so This is basically this is how you create a map. So you have a focus area, you have a complete as an overall area, you have a legend, you have north arrow, you have a scale, all of these things, this is how you represent. Okay. There are several maps. This is all much more theory, you will not be interested in this thing. Classifying quality and quantity. You will classify quality and quantity data. Okay. So you have normal maps, you have ordinal maps, you have interval maps, you have ratio. So basically based on these data types, you define what kind of maps you want. What is nominal? Red, blue, green, yellow. Red is brighter than yellow. That kind of thing is nominal. What is ordinal? Quantitative data. Anything that has quantity is ordinal. What is interval? Anything that is regular interval, like rainfall falls every monsoon. Morning, if there is 6 hours a day, 6 hours of night, or 12 hours a day, 12 hours of night. Anything that has a proper interval, or temperature, or whatever. For every 100 degrees, temperature reduces 1 degree. That is an interval. That is called interval data. Then ratio. This is where your statistical analysis comes into play. If the results of your analysis is always a ratio, numeric. Okay. So based on this thing, you will choose your maps. Okay. See, if there is only nominal data, you choose this tourist map. Okay. See, there is this thing, there is that, there is no direction, there is no perfection in area, nothing like that. You just say red color is your visiting sites, blue color is your road network, whatever, all of that you do. If you have a complex data to be represented, like military maps, they require directionality and precise connection. You use much better projection, accurate projection data. Something like you need to only, this is called ratio, statistical data. You want to represent a statistical data, you can go for this kind of maps where you represent the no pie charts and all of that you can use for a particular region. So all of that different, there are different maps for different purposes. This requires storage of directionality. Yes, because where from this direction, if here I want to go here, I want to follow the direction. So the directionality have to be stored in this map. So you will choose a projection that gives you best direction. That gives you the best direction, not the area or distance. Probably distance and direction is what you are looking for. Then come tidal movements. You want to see, you want to represent how the tides are moving. So this is a ratio, interval and ratio. So you will use different maps that give you more accuracy in direction and movement area. So you use those kind of projection systems. Similarly, there are for different purposes. There are different maps. Here you are trying to project your saving area. What is this thing map? Population density. So population density is ratio. Or you can choose, because density is based on area. You want to use a projection that saves the area property much higher with higher accuracy. So for that you use a projection like UTM, Universal Transform Marketer. This is map where you want to save the shape. You can go for conformal or you can go for compromise projection system. Like that, based on your analysis, the location, what you want to show, you can choose different maps. What does topo sheet? This is a topo sheet, basically very high topo sheet. So you can choose. I mean, this is not required. I mean, this is for some other study. This is all required. Yeah, one thing is I wanted to show you this thing. Okay. Yeah, this is geological map. So you can use different legends and everything to make your map more beautiful. This is the statistical map. Okay. But if you want to show something, for example, you use a regular map and say, see, I flew from the distance between New California and London. Is this thing? Then you are wrong, because the distance has to be measured like this. So for this reason, you use a different projection system. So based on that's what this is how the impact of projection system will fall on your analysis. You say I will use GCS system, I mean global coordinate system, and WGS80 for Datum to predict distance. You cannot get accurate results. You will have to choose a particular projection system for your particular need. Okay. Then comes the, I wanted to show you the one more thing. What is that? Where is that? This thing. See, with certain projection, North Korea has a missile. It has 1000, 2000, 3000 square kilometer range. If you see here, India falls onto this, only this part of Africa falls onto this, only this part of America falls onto this. But this is wrong. This is wrong. Okay. So you need to use an accurate projection system or a global projection system such that now you see the accuracy 1000 kilometers, 2000 kilometers, 3000 kilometers. Almost northwest of entire USA falls under the missile range. Okay. That is what it is. So your choice of the projection will impact your analysis results. So be careful while choosing the projection. But if I use a different projection, like a global projection, or now even though you are doing concentric like this, this is more accurate. So based on your projection, the accuracy depends. That's all. These are all different types of projection systems. See here, I wanted to give an example of 2 or 3 projection systems: Robinson projection, Miller cylindrical, and Chile UTM 18. So based on this thing, you see the shape shift and size shift. So based on your projection, you also concentrate on these squares here. You see how the squares are tilting. You see how the squares are changing. So your data depends on UTM or depends on the projection. So be very careful of choosing your projection system. Okay, these are all not part of your syllabus, so it's okay. So oh my god. Okay, then I will end the class here. I will anyways give you this a PDF of this thing. Okay, so that and also the recording, so that you people can go through this thing, go through the data. Okay, tomorrow we'll start practicals. I'll tell you, sir. Tomorrow we'll do map. I mean, Prashant sir, we are doing map projection again. So if you are interested, you can attend again because you're already done with that class. It is up to you, sir.
Which time we are in the afternoon?
See, for you, I'll take anyways 2 to sir 12 to
1,
2.
12 to
12 to 2.
Okay.
So if Amit wants to attend that class, he can attend.
So 12 to 2 tomorrow, no?
Yeah, 12 to 2.
Yes,
But
sir.
if you attend the morning class, you cannot attend the evening class.
Yes, sir.
Okay? Yeah. Yeah. So decide that and tell. You can actually tell Vijay also. Forward that to Vijay sir. I came to know that Tarun sir is taking from 12 to 2. You don't have to call me Tarun sir and all. You just call me Tarun. Okay? Tarun is taking from 12 to 2 also. So I want to shift there.
Okay,
So that should be great. But see, for me, it is easy when everybody is together. Okay. So if ma'am gets her Wi-Fi connected, I would request her to change her timing to 8 to 10. That would be a great.
Okay. By this week, I guess. By matlab, this week, most probably.
Yes. Because and then I also want to request Amit also, please, if you
sir.
Till
you can
then we'll
yeah. Till then you can join 12 to 2. But after
Okay.
that, come back to the 8 to 10. Okay.
Okay.
There is another participant also. He is not here yet. He or she, I don't know. So he will come or she will come. Then we'll have 4 participants, and then I will request her.
Okay.
So
Sir, by this week.
yeah, fine. By this weekend we'll shift to 8 to 10. Everybody. Okay. Sir, hello, Prashant sir.
Yeah.
So tomorrow are you attending the class?
Yeah, I will attend.
Oh, okay. Sir. Thank you,
Because
sir.
same time I will be practicing.
Achha, absolutely.
Yeah.
That is a great thing. That is a great thing to do.
Yeah.
Thank you, sir.
Yeah.
We'll meet tomorrow.
So Yeah, I prepare. Sorry, you need not to call me sir also. I'm just
No,
Prashant,
you are
and
way, you are way too elder.
uh,
You have much more experience, so I cannot help it.
no, it's okay because where we work and this environment, nobody calls sir. Sir is like a Sir Isaac Newton only.
Mhm.
Sure.
Okay,
Okay.
yeah, I was having a small query.
Yes, yes.
Maybe I found, but I think maybe I found a problem because I was trying to change the polygons into polylines, and I was
Oh,
following my old method, going to create feature, copy, paste. But
don't
then
do
I
that.
think now,
Now it is easier. Yeah.
yeah, now I think in toolbox that in feature,
Yeah,
feature
yeah.
to point, feature to polygon, I will use that. Sure.
Yes, yes. That is the best way to process.
Yeah. Because I was going with my old method. That
Yes.
was taking a lot of time. Okay.
Yes.
Thank you.
Thank you, sir. So I'll share the recording of this class. Okay. Chalo. Bye bye. We'll
Okay.
meet tomorrow.
Thank you. Bye.